So our course title Communication Principles, and today we'll start with the first chapter. This chapter is on introduction and noise. Okay, before I start, I want to just introduce a little bit about myself, because I believe many of you have not met me before, right? I'll just turn off the video and continue with the lecture. Okay, I'm Nadia Turuda Zulkifli. You can call me Dr. Nadia or Puan Nadia, it's all right. My room number 031400 in block P19A, level 3. You can contact me through my email, and this is my phone number. Okay, if you want to PM me through Telegram or WhatsApp, it's also okay, no problem. Wait, more are coming, so I have to stop and let them in first. Okay, in terms of department, before it's known as department, but now division. So it's Division of Communication Engineering. And my research group, my specialization is in optic. So I belong to Light Wave Communication Research Group. Okay. So we'll conduct our class until now in Google Meet, and our main platform is Google Classroom. Okay, the slides, assignments, everything, submission will be in Google Classroom. So please make sure that you join our Google Classroom. Okay, a little bit about my personal family life. I'm already married with 4 children, 2 boys and 2 girls. And this is my handwriting. Okay. So if you want to know more about my personality, you can check on my handwriting. Okay. So today's class, because it's still introduction, so we'll just like when you're driving a car, first you'll start with gear 0, right? So today's class will be a little bit relaxed, introduction to our course, and also what course overview. I think somebody is waiting. Okay. So first we'll look at the program learning outcomes and course learning outcomes. We have 2 PLOs, PLO1 and PLO9, and 3 CLOs, CLO1, 2, 3. Can refer to the attached CI, course information, that I put in the Google Classroom. Okay, so PLO1 is about the application of knowledge, while PLO9 is on the, if you look here, in relationship with between the role of engineers and its impact to the society. So for CL1, we demonstrate important concepts in communication systems like modulation, multiplexing, with the aid of time frequency domain analysis and evaluation of communication system performance. Okay, so will all our classes be synchronized? Sorry, it will be mixed. Okay, lecture online. I'll also put offline for those who cannot join synchronous. I know that there's time difference or other problems with internet. Assignments, everything in Google Classroom. Okay, we go back to our slide. Okay. So we have 6 chapters. If you look at your CI, we have 6 chapters, and all the chapters are within this CLO1. Okay, so much of the weight, 75%, will be mapped to CLO1. And then CLO2, apply mathematical equations in simulation software to solve problems in communication system. So this one mapped to PLO1, and this is achieved through software project and software assignment. And third, CLO3, evaluate relevant telecommunication scenarios through case study to address global impact and professional engineering issues. So this will be assessed using two methods. First, case study project, and another 5% will be assessed through test, your test. Okay, more on course information. So now we'll look at how we distribute marks for this course. Okay, it will be 50% coursework and 50% final. And for the 50% coursework, 20% will be your test. Yeah, it's quite a lot, 20%. Before we have 2 tests, but because of the difficulties and the challenges with online tests, we decided to have only 1 test, but it carries 20%. So we decided to have it on the 3rd of December, not 2019, it's 2020, sorry. So it's 3rd of December this year. And it covers from chapter 1 until chapter 3, production, noise, analog modulation, AM and FM. It will be online. And then for the others, 10% case study assignment. So this one, you have to prepare a YouTube video. It's a group-based YouTube video and submit through YouTube. 10% software assignment. Okay. So for the instructions of these 2 assignments, the YouTube video and software assignment, I'll put in Google Classroom later. And quizzes will be 10%. Okay. I want to make quizzes for every topic, or not every week, maybe sometimes 1 week or 2 weeks, depends. So there will be quite a lot of quizzes lah. But don't worry, normally short quizzes. Okay, 50% from your final exam. So if you notice, when you register this course, it's a blended learning. Yeah. So we hope by early next year, all this we can start face-to-face. Yeah? So your exam, we hope, can be done face-to-face instead of online. Okay, so if your attendance is less than 80%, I have the right to bar you from attending the exam. And proof of your attendance is the reflection. Yeah? I'll ask you to submit your reflection after each class. So due date will be on the day's midnight. So timing, everything will be based on Malaysian time. Okay. So it's Malaysian time's midnight. Like today, the reflections due is by 11:59 p.m. Okay. Okay, any questions so far? If you want to ask, you can just unmute. If no, I'll proceed. If there's a problem, you cannot hear me, anything, let me know. Yeah. Okay, if you look at your CI, there are a number of references. Okay, normally we sell books. Yeah, you can get the books from labs, but since it's online, you can
Excuse
try
me.
your luck and Google the reference books. Some of the books are available, the soft copies. Okay, let's continue if there's no question.
Excuse me, doctor.
Yeah, Abdul Ghani,
If someone is absent of the class, yeah.
absent with the class. Yes.
He still can do the reflection as well. So I think this is not like efficient proof of
Okay, because
attendance.
I know due to many problems, not every student, thank you for your feedback comments. Not all students can attend the online synchronous because of internet problem, etc. So normally I'll post the recorded version, and then those with the problem can watch later through like maybe YouTube or pre-record video download. So the reflection, yeah, if you don't watch the video, you won't be able to do your reflection fairly. Okay, is that okay? Is it fair? Do you think that reflection is unfair or how? Okay. The quizzes contribute to 10% or take few with better marks. Okay, I'll choose 4, 4 or 5 depends. I'll choose the best 5. Okay, for the quizzes. If you have a better idea for the attendance, yeah, you can let me know. I'm open to suggestion. Okay. QR code. Okay. I'll explore that. Okay. Okay, let's continue. First, I want to show the overall overview of the course. Yeah. So we call it concept map. Okay, we start with introduction. So in this introduction, we have we learned about the basics of communication system. We learned about the parameters that are important for communication system performance. Yeah, like bit rate, bit error rate, signal to noise ratio, bandwidth, etc. We learned about a communication system, how it's related to society, some regulation. This is not, we won't go very deep. It's just kind of introduction, and it just is to expose you with these things. And noise. Okay, so introduction noise will be in your chapter 1. Okay, and this course, and most of the contents, you can classify into analog and digital. Okay, for the analog part, we have 2 main types of modulation, amplitude modulation and angle modulation. Okay, for amplitude modulation, we have the with carrier and suppressed carrier. So under this, we have the single sideband and double sideband. For angle modulation, we have the frequency modulation and phase modulation. Since both are quite similar and has many similarities, we'll focus only on frequency modulation. So under here we have the narrow band, wide band categories. And for the both amplitude and angle modulations, we look at the study the modulation index, power, the frequency, how to generate and detect these signals, its bandwidth performance, and also noise performance. Okay, but the noise performance for these modulated signals, we won't really go very deep in it. Okay, for the digital part, we have chapter 4, pulse code modulation. Okay, in here, the emphasis will be on the processes for analog to digital conversion, like sampling, coding, quantization, and also line coding. And then chapter 5, we learn about modulating these digital signals. Okay, so you have ASK, amplitude shifting, frequency shifting, phase shifting, quadrature phase shifting. And we'll also look at the system performance for these modulation techniques. Yeah, but almost similar to the analog counterpart. You have modulation index, spectrum, bandwidth, how to generate and detect noise. But additionally, for digital system, we have this parameter of bit error rate. Okay, and finally, our last chapter, multiplexing. Okay, multiplexing is a technique in communication to increase our bandwidth efficiency. And we have frequency, space, time division multiplexing. Okay, and this multiplexing actually covers both analog and digital. Okay, so this is the overall concept map for our course. Okay, so any questions so far? No?
Doctor, is there any
Okay.
resources we can refer?
If you go to your CI, they said, people said, the lecturer said that you can Google the first reference book. We used to sell the hard copies, but it's impossible now. Yeah, so you can just Google. Okay, any other question?
Is to rely on the slides only?
Relies on the slides?
Yeah.
You can read also online books. Like I said, I was told that the first book is available online, the soft copy. Yeah, so you can read those books.
Okay, doctor.
Okay, reading from slide I think it's better if you can read, to improve your understanding, to get some fundamental knowledge. Okay, so let's.
Do you have any soft book, PDF book?
PDF book?
Yeah, do you have any?
I cannot distribute. It's illegal.
Okay.
But if you want to do it, then we can't stop you. But as for me myself, distributing, there will be copyright problem. Okay, copyright issue.
Thank you.
Okay. So let's start with some introduction to our course, especially introduction to communication system. Okay, we'll start with some questions to ponder, like how do you send data or information to someone who is far from you? If the information that you want to send is your voice, how to make sure that what you are saying is understood by a friend? And what is the source and technology available around you that can help? Okay, we communicate a lot. Yeah, if it's with someone who is close to you, next to you, Yeah, then it's no problem. You don't need any technology. You just need mouth, yeah, and ear. Of course, inside your body, it's not that simple. You have throats and everything, esophagus. But if it's someone who is far from you, of course, we need technology to help, yeah, to deliver the information. So, like we have our friends here that not in Malaysia, yeah, even in Malaysia, we are all over, like in Semenanjung, Sabah, Sarawak. So, how do you think that delivering this information in long distance is possible? What are the source and technology
through the
you
antenna.
think? Antenna.
Antenna.
Okay,
Yeah.
good. And
Internet.
internet. All right. 5G. Okay. So those are all the terms, yeah, that you're familiar with, right? Yeah. All these communication technologies that we're familiar with, because they're all around us. Yeah. We communicate. We can't live without our phones, laptops, etc. Yeah. And we know that there are technologies, name of these technologies, even though maybe we don't know really in detail, but we are familiar with the terms. Yeah. 5G, what else? Unify, and all those things. Okay. So let's take myself as an example, how I communicate, yeah, with family members, like you students who are far from me. Okay, I have what are my communication devices? Phone, right? Smartphone, television, laptop, radio, yeah. And even television, we can see the developments in terms of the different technologies that we use. Yeah? You may notice we have first started with free television, right? Yeah, free government, yeah, and television. And then Astro was introduced, and then later HIP TV, yeah, through Unify, right? So here's we have radio, laptop, phone, TV. It's all blended into our life. Right? It's part of our life. Our lives seems imperfect without them, right? And what are the information? What types of information that we received on these devices? Yeah, it can be before with the old phone used to receive only, listen to voice only, right? But now the phones are getting sophisticated, and not only voice, you can read text, watch image, even videos, yeah. And all these are also available in laptops, with laptops radio. You just listen to voice, yeah. Television, many videos, and audios. Okay. So these are what we transmit and we received, this kind of information signals, and these are the devices that you have. And these are some of the terms, yeah, that we are, I believe, very familiar with. You mentioned about antenna, 5G. We have also transmitter, receiver, modem, wireless, satellite, cable, unified, remix. The antenna and 5G that you guys mentioned belong to this wireless technology. Yeah. And wireless, satellite, cable, unified, remix, all these actually belong to different medium type, and different media. And if you notice, they have different frequencies, and the media depends on the frequencies. Like when you use Wi-Fi, it's 2.4 gigahertz, right? So what else? If it's your radios in hundreds of megahertz, right? Or 80, 90 something megahertz. Okay. And yeah, it's very associated with frequency. Yeah. And we have also the modem. Do you know what modem is?
Yeah, doctor.
Yeah, modem. Anybody?
Yeah, it connects all the. No. The modem connects all the computers in your house to the internet network.
Okay, so normally you notice modem is the one that it's like a device and that connects the main cable that you receive from this provider, and then you connect the modems to the other devices that you have, right? Okay, modem is actually known as modulator and demodulator. Short form for modulator and demodulator. So normally located at their transmitter or receiver device. Can be part of your router. So modem changes the frequency. So this our course we will learn a lot about modulation and demodulation because it's a very important process. Important processes in communication system. Okay. We have also router, switch. Okay, so this like router or switch, it's like how do you channel, to different applications, different devices. If you have, for example, many laptops connected to your that needs internet connection, then you need to have a router, right? Okay. Because all these devices, they will be addressed to different IP address. Okay, but modem and demodulator is very related to the physical properties of your transmission. It's very related to frequency. Okay, why? Because your voice, image, video, voice, for example, frequency is up to 4 kilohertz. Yeah, if audio like voice, audio like music can up to megahertz. Yeah, your video can be gigahertz. Okay. Voice, for example, in 4 kilohertz is low frequency. Okay, but your medium, everything you will look later, high frequency or different frequency from your information. So modem, it will modulate, change the frequency of your information signal to the frequency that that is suitable for your medium. We have all these different mediums. Your medium, you basically use the same type of information, but for example, if it's voice, there is voice, but your medium can be, different. If it's it can be from laptop, from phone. Okay, so laptop and phone, they're based on different frequencies and the medium that you use for the transmission part. And this medium basically connect your transmitter and receiver. Okay. Okay, Jason, yeah, you mentioned about router, all right. That's okay, we all are learning. Okay, so from the introduction and from what we have shared, so it's still part of our society, communication, it's part of us. It's like our needs already, and it cover many aspects, social, business, health, education, okay, of our society that depends on communication. So in order to protect public, we need regulatory body, so especially the public lah, they need to protect and interest of the public. So from here we'll move to the a bit history for the regulation. Okay, worldwide we have this ITU, International Telecommunication Union, So it's a specialized UN agency for ICTs. And then ITUT, it will gather experts from around the world to produce international standards. Okay, so it's called as ITUT recommendations. Okay, so standards are very critical to global interoperability of ICTs. Okay, so that's why we have devices made in China or Korea can be used in other countries because the standards ensure that they are compatible and highly compatible across the globe. Okay, of course, sometimes there's slight things that you need to adjust, but if you don't have standards and recommendations, it will be very difficult. Okay, you can refer to this YouTube video for more information on ITUT. So there are three sectors of ITUT. The one that manages the spectrum and satellite orbits. Because spectrum in communication is very valuable resource. If you notice in our media, then there were like issues and complaints about the spectrums allocated to all these telecommunication companies. Okay. ITUT for developing the ICT and telecommunication standard, and also ITUTD to assist the developing countries. Okay, so with the compatibility at the global audience, we provide universal access to basic telecommunication services, and it will also make market be more competitive. So this is for the best interest of consumer to have a good competition in the market. There's no monopoly. Okay, so also promote public confidence, protect consumer rights and everything, to optimize scarce resource allocation. Okay, so like I said, spectrum of frequency is very valuable resource in communication, so you have to utilize it, and then we need somebody to manage it. In Malaysia, SKMM or MCMC. So this is Malaysian Communication and Multimedia Commission, or Suruhanjaya Komunikasi and Multimedia. So this is the regulatory body and that decides the ICT matters. It also promotes awareness about digital society to our public and ensure the it's highly digitized our society, and also enforce for law enforcement related to SKMM, especially in this today's age. There are lots of issues with social media, etc. So there's also law enforcement in this aspect. And in Malaysia, in Johor, it's also important for MCMC to manage the spectrum because we have many neighboring countries that can cause frequency interference. So we need to make sure that they also need to talk to all these countries to make sure that there's no interference in all the services. Like if I want to, for example, introduce a new radio station, I have to make sure that I have to choose SKMM will decide the right frequency, so there's no interference with other neighboring countries. Okay, so can say that communications and the network societies can achieve full potential of a nation. So it increases many things in our life. Even now, we can learn online. We can also save labor, right, with the industry 4.0. So some parts can be replaced by machine and intelligence. Okay, and with faster communication process, it helps in business, in many societal aspects. So especially during this COVID-19, can you imagine without ICT, can we survive? Yeah, so especially the first PKP, where we had to sit in, we were not allowed to go to many places, right? So without ICT, we couldn't conduct online classes. Yeah, and we couldn't order things online, things, important things like basic foods, groceries, medicine. And one businessman also agreed that I had the privilege to listen to his lecture, and then he said at that time they decided to go online very aggressively, because if not they will die in the business. So especially during COVID-19, we saw how ICT is actually our lifeline. So, all right. So these are the impacts of communication, communication system to our society. Of course, there are also the adverse or negative impacts, okay, that I didn't put here. For example, the placement of, if we are too exposed with telecommunication towers, if it's very close to your house, then could be effects of health hazards because of radiation. So that's why when 5G is to be introduced, 5G is the hot topic right now, and it's very welcome in Malaysia. However, in certain countries like US, Europe, they were very critical about it. They said that because of the impacts to people's health and security issues, and so they were very critical about it compared to us. And okay, if we overly rely on ICT communication also, it's not very good, because if you spend lots of time just sitting, watching things online, then our health also will be affected. So those are examples of negative impacts from communication technologies. Okay, so any problems so far? Anything that you want to add or comment? Okay, somebody just joined, poor thing. Okay. So we'll continue. Yeah. If no problem, you can still focus. It's good. You can continue with theoretical part of our course. Still in introduction session. Okay. So what is a communication system? We know that there are various types of communication devices, different types of medium, but fundamentally is the process of sending information signal from one point to another point. So that is a communication system. Telecommunication refers to the long distance, right? Long distance communication system. And it involves three important processes: transmission, receiving, and processing. Okay. So we have transmitter and receiver. And here is the block diagram of a communication system. Okay. With your phone, for example, Okay, you have your transmitter and receiver both at your phone. Of course, you cannot see because they are all wrapped, package. And your medium can be wired or wireless. Okay, so let's look at the block diagram. Okay, first we have our ST, your input signal. It can be various forms, but this is the original form from the source. Like if it's a human, so it's our voice. If it's your laptop, it can be text, video, etc. So depends on the source of our information. Okay, so input transducer will change from ST to MTX. So MTX is the modulating signal. So it changes from the original form to electrical signal, or to electronic form in electrical signal, because basically our communication devices are electronic devices, like your phones, your laptops. They are electronic devices. They understand only electrical signals. Okay, so when you convert, it becomes modulating signal. Okay, from original input signal, it becomes modulating signal. And then after the transmitter, at the transmitter, there are number of components inside the transmitter, but important ones is modulator. Okay, so modulator will change the frequency of your modulating signal to a frequency that is compatible with our medium. Okay, and then once you arrive at the receiver, demodulator will demodulate from electronic or electrical signal. From demodulator will change the frequency, and then this change frequency of modulating signal will be converted back to the original form. And this is where we get our RT, the original form of our information signal. Okay, and inside our communication system, we also have signals that we don't want, but it's there, which is noise. So noise can be from mediums or from other components inside the transmission system, inside the communication system. So if noise resides with the same frequency of our information signal, then it's more troublesome. So noise can be, if it's wireless, noise can be from the environment. Okay, so we learn about noise at the later part, second part of our chapter 1. Okay, so chapter 1, introduction and noise. Noise is the second part of our chapter 1. Okay, so these are the descriptions of or definitions of our block functions just now, like input transducer, convert the input signal to electrical forms such as microphone. Okay, transmitter involve modulation process, convert modulating signal to modulated signal. Okay, once modulated, when it's suitable for our medium, then finally we transmit the signal, and then transmission medium just basically carries the modulated signal. The receiver will demodulate, and the output transducer will change back to the form that we can understand. In here, for example, loudspeaker. Okay. Next, I want to introduce to some concepts that are also important for communication system. First is analog versus digital system. Okay, so analog basically is the most common before we have all these laptops and binary. Analog is the most common and natural form of original information signal. Yeah, like the temperature, voice, pressure. Naturally, they are in the analog form. So that's why it can take any value within a range. So an analog system, yeah, these signals, this analog system should be able to take any values within this range. Okay. For example, audio amplifier produce an output voltage which can be valued within the range of its power supply. Okay. So this is different from a digital signal. So digital signal, it has limited values. Binary digital. So binary is a form of digital system. So binary, this is the 1 or 0, true or false. Like that. Okay. So can you share any other analog or digital system that you know? Anybody? So I know that we're there, not sleeping. Yeah. So can you give an example of analog system?
Temperature.
Temperature. Okay. That is the information type, the signal type. But system?
For the system, can be multimeter.
Okay, the analog multimeter.
Yes.
Yeah. Okay, what else? The
speed counter in the car.
yeah,
Mileage.
mechanical watch. Yeah. Voltmeter, the speed meter, speedometer. So we decide the minimum and maximum, but basically it can point to any values within this range. Yeah. Weight machine, okay, right, weight machine, yeah. Okay, oscilloscope, okay, good. Okay, digital system, I think we have so many examples about digital system. Okay, Nokia 3310. Okay, my computer, your smartphones, smartwatch, yeah. Even now we have digital-based weight scale, digital-based, what else? Watch, right? Temperature can also be in a digital form. Okay, so there's one, there are many advantages of having digital system compared to analog. So one of them is noise, okay? Because analog system is more sensitive to noise, okay? Since it can take any value, so the system recognizes any value from minimum to maximum. So it cannot differentiate with if you have noise within this range, whether it's noise or it's actually useful signal. Okay. Unlike digital, because it's either 0 or 1. And 0 you give like maybe 0 volt, 5 volt. So if you have value noise that is noise in the system, okay, and it mixes with your information signal, your original voltage, instead of 0 it becomes maybe 1 or 0.5. It increases a bit because of this noise, but you know that it is still 0, because normally digital system you have threshold, and then you have certain range. If it's from maybe 0 to 2.5, 0, 2.5 to 5 is 1. Okay, so normally noise is also not very high voltage, so little bit addition to our original signal, it shifted a bit, but you know that it is still 0 or it's still 1. Yeah. Okay. So it's already 2:50. Do you need a break or to continue? And normally, if it's a face-to-face class, we have 10 minutes break, 2:50. But do you want to continue? Can continue. Okay, good. Okay. This system. Now we look at the signal classification. Okay, how do we classify signals? These are your information signals, right? Okay. So the signals, can be continuous or discrete. Continuous. It when it has continuous in terms of time. Okay, if you look at the slide, so your x-axis, the t is continuous basically. So discrete, it has certain fixed intervals. Okay. Okay, so your signal can be so it's discrete in terms of time, discrete time. Can also be analog or digital. So analog, so your amplitude of a signal can take any value within a continuous range. Digital, only finite values. So you can have analog but discrete and digital continuous. So it depends on your timing. So analog mainly with your y-axis voltage, and discrete or continuous depends on the x-axis, your time. Okay, and it can also be periodic or non-periodic. Okay, so a periodic, there's no repetition. Periodic, it repeats itself after a certain period. So if our period, for example, is t0, then xt is equal to xt plus t0. Okay. So this is just an example to prove, that a sinusoidal signal is actually a periodic signal. Okay. So you have here your xt equal to a sine 2 pi f0 t plus theta. Omega is equal to 2 pi f. And then your t is equal to 1 over f. So basically, we replaced when xt is the top and xt plus t0 is equal to a sine this f0 replaced with t0. Okay. So it's xt plus t0 replaced this t0 with 1 over f0, and then we have in our equation the terms omega naught t plus 2 pi. Okay, and this can be further expanded using identity, trigonometry identity. Okay, sine x plus y equal to sine x cos y plus cos x sine y. Okay, you expand your equation, and then you get this part, below part. So since cos 0 or cos 2 pi equal to 1 and sine 2 pi equal to 0, we simplify this equation, so it becomes sine omega naught plus theta. So from here, we prove that xt plus t0 is equal to xt, which is equal to a sine omega t plus theta. Okay, so this is just an example Yeah, in terms of analysis on the periodic signal. Okay. And we have also harmonic signal. Okay, what is harmonic signal? Okay, harmonic signal is when if you look at your sine signal, we have only like very nice sine shape. So this is your fundamental frequency. Okay, so fundamental frequency normally it has high amplitude. Okay, but harmonic is when apart from fundamental frequency F, we have also the multiples of the frequency, like 2F, 3F. So signal can have second harmonics, third harmonic, etc. Okay, so practically almost all signals have energy at harmonic frequencies. Okay, so that's why in your signal analysis, I'm not sure if you have learned DSP or not. Okay, but you can actually split the signals into their fundamental and the harmonics. Okay, so our voice, for example, it has harmonics. So the shape is not really nice sine signal. So the higher harmonics that we have, the more sharp our information becomes. So for example, a perfect square wave will have infinite harmonics. Okay, you can see here, okay, like this one, the blue dots, and the first paragraph, blue dots, is your fundamental. Then you have the second harmonics with orange dot, and when you mix these two, it becomes signal that looks like our teeth, gigi, like your teeth. Okay, so this is the signal that it consists of the fundamental and the third harmonics. Okay, okay, so when you have more harmonics like this one, it has up to fifth, then you can see there's more ripples. And if it's nearly infinite harmonics, then it would be nice, sharp, perfect square wave. Okay, so these are the representation in time domain. Okay, remember in our CLO, we mentioned about the time domain and frequency domain analysis. So this is the time domain, this is how it looks like. Okay, this is your signal. It looks like this, like your teeth when you were little, gigi susu. And if you look at the frequency analysis of this time domain signal, you can split from fundamental to second harmonic, fifth harmonic, for example, third harmonic, whatever harmonics you have. So in frequency domain, you can see that the frequency, the value, and the amplitude for each frequencies. Okay, you cannot see this in time domain. The time domain, the signals are all mixed. You can just see the shape of your signal. Okay, so any questions so far? So what is a harmonic signal different from other signals? So how is harmonic signal different from other signals? Okay, Jason. Harmonic signals is a way of classifying your fundamental and harmonics. So almost all signals have harmonics. Okay, like our voice, not only we have fundamental, but we have the high energy signals. But when we go the higher the harmonics, the energy will become lower. Okay, so sometimes that's why if our system is frequency limited, it doesn't permit high frequency, then we can just ignore the very high harmonics because the energy or voltage is low. Okay, so signals without harmonics, only fundamental is just the cosine and sine signal. This is the fundamental. Okay, I hope that answer your question, Jason. Any other question? Harmonic is like music. Yeah, music has, of course, music audio signals has harmonics. Yeah. Okay. So let's continue. All right. Let's look at medium. So we have medium, wired and wireless. We can also call it guided and non-guided. Okay, so if you remember, when we first used our internet and when TM Telecom Malaysia introduced internet service to our homes, it's based on Streamix, right? Streamix. It's called the product is called Streamix. So Streamix is based on copper. So copper carries electrical signals. Yeah. So there are different types of copper, from twisted pair to coaxial. So better copper has better performance in terms of loss, the frequency, speed, etc. Okay, and now you can see that at homes, Streamix is already old-fashioned. If you say that what internet you're using Streamix, people will laugh at you. It's so old-fashioned. It's very embarrassing, right? Okay, so everyone now is talking about Unify fiber, TM fiber. Yeah. Okay, so with Unify, for example, okay, it uses different types of wire or cable. It uses fiber optic. Yeah, so fiber optic, it carries not electrical signals. It does not carry electrical signals. Fiber optic is made of glass, silica, or plastic. Yeah, so it they are type of insulator. Insulator, they do not carry information signal, but they carry signals in the form of light. That's why they can go very fast. Because they operate at very high frequency, and that's why before your TM in your house, you have different service provider, right? Astro for your television, TM for your internet, and also for your phone. Okay, but now with Unify, you can, with this one service Unify, you can be connected. You can be offered internet, phone, television, lots of channels. Yeah. So because of the capacity, that is allowed by fiber optic. Okay. So even 5G, all these high-speed wireless networks like 5G, 6G, etc., is impossible to be realized without fiber optic, because fiber optic act as the backbone. Because all these high-capacity wireless networks, the higher capacity, the smaller the cells. They are also cellular terrestrial technologies. So what's connected between these towers are fiber optics. Okay. And then we have waveguide for the antenna, guiding wireless signals. These are the guided cables or mediums. We have also wireless or unguided for different types of services like the cellular phones or satellite broadcasting, etc. So like your friend said, you mentioned about antennas. So we have all this. Wireless is very associated with antennas. Okay. Okay, any questions so far? Are you with me? Or you have to pay attention. Later you have quiz, you know? All right. So you continue. Good. Where is my slide? Okay. Now we look at the transmission medium. Okay. So with our medium, and this medium basically to support long distance communication. Long distance communication. So attenuation is a major source of transmission loss. Of course, the longer your distance, the higher is your loss. And the loss depends on the medium type. Okay. So attenuation occurs along the transmission medium, will attenuate the signal power. For example, you have when you transmit, you have your input power, certain dB, certain input power, and then after going through the medium cable, it will be become reduced, the power at the receiver. Then if we don't have amplifier to overcome the losses, then the signal will be much reduced depending on the cable length. Okay, so attenuation is basically a loss. Normally, the unit is in dB. It's equal to P in over P out. It's also equal to 1 over G. So in dB, we just 10 log. Log 10 of our P in over P out. Then we got L, loss in dB, which is inverse to gain. Because gain is supposed to increase your power, but loss, it reduces your power. So attenuation, we have attenuation constant. The unit is dB per kilometer, and total loss, and just you times your attenuation constant with length of the transmission medium. So attenuation constant depends on the medium type. So your medium, and medium is also can be classified into different frequencies. All this medium has different operating frequencies. Okay, and at different frequency, the attenuation is also different. Okay, so fiber optic cable, its main advantage is that it has very low loss at high frequency. So higher frequency meaning that you can transmit high bandwidth, high bandwidth signals. Okay, high bandwidth signals are like your video in gigahertz. Low bandwidth signals like your image, in megabit. So attenuation related to your distance. Lower attenuation meaning that you can go for longer distance. So that's why if you want to transmit more than 10 megabit per second over 1 kilometer, then you have to use fiber optic, something like that. There's a rule of thumb. Okay, so so basically fiber optic, it helps in revolutionize the communication system. It allows transmission of high capacity signals, large bandwidth applications, over long distance. Okay, and you can wash your face. I know it's in the afternoon, you just had your lunch, so it's quite sleepy. All right, so this is the frequency spectrum. If you look at the frequency, so the frequency, and then on top of wavelength, just inverse. High frequency meaning very low wavelength. So that's why your phone, for example, the latest technology with high frequencies, the antenna is very small, because the antenna dimension is directly related to wavelength. Okay, so if you look at the earlier types of applications like telegraph, it uses very low frequency, low bandwidth. Okay, phone, etc., up to very wideband data in terahertz, gigahertz. So this we use transmission media optic. Okay. Okay. Some more on the parameters, to determine the efficiency. How do we know that our communication system that we design is good or not? Okay, so there are a few questions that you need to ask. Like, how close is your received signal to the transmitted input signal? Okay. So this is much affected by the noise. So noise, we have the parameter here, signal to noise ratio. Okay, if our determine the difference between your signal and noise, of course, if your noise is lower, then it's better. Okay, bit error rate is out of how many bits you have sent, how many are the errors, and then how much power is needed to transmit your modulated signal. Okay, if your signal needs high power, then you use your battery faster. So that's why your lifespan is shorter. This is inverse to the low power. If you can propose signal application that use low power, then it's better for your battery or energy. Bandwidth. If your application use less bandwidth, then the communication medium can be shared by many users. Okay, this is like example of if you use Wi-Fi. Okay, if many Wi-Fi users, if you have in your home, for example, okay, you have many family members connected to one single network at your home. If one or two use video, then you notice the others have difficulties to connect because video uses high bandwidth. So especially if it watches films that needs high bandwidth of a long time. If it's just texting, WhatsApp, then not involving high bandwidth applications, then many users can share the same Wi-Fi network. Okay, so analog system depends on the signal bandwidth, and digital system depends on bandwidth and also the bit rate. Okay, because it involves bits with digital signals. Okay. Is bandwidth related? Okay, what ST and RT means? Okay, sorry. ST is the transmitted signal. RT is the received signal. Yeah. Okay, received and input signals. Bandwidth related to speed. Okay, bandwidth is normally related to the frequency that we have. Okay, how it is related to speed is if how can I say, if for example you have a medium with high frequency and large capacity, then the speed is faster. Okay, that is how we increase the bandwidth, increase frequency. Wait. Okay, this slide. I think there's an explanation after this. Wait. Okay, I'll talk about bandwidth and bitrate in this part. First, I've just finished. I'll explain on that later. Okay. This is in terms of noise and power. Yeah. So there are obstacles to the efficiency of communication system, technology problem, and physical problems. What we learn in details for our course is physical problems like bandwidth, signal power, noise. The technology problem, we just touch little bit on the societal impact. So it can be related to law, ethics. But we didn't discuss much on the hardware economics, so maybe we learn this in another course, like sustainable engineering. So, okay, so these are important parameters in communication system. Your friend asked just now about speed, bandwidth, frequency. Okay, so these are the explanation. Okay, bit rate is basically the number of bits that we send per second. Okay, so it's important for digital system because it deals with bits, binary bits. Okay, so the bit rate is associated with bandwidth, and bandwidth is basically a range of frequencies. So your friend asked just now, how do we increase the bandwidth? Do we increase the frequency? Okay, basically we increase the frequency range. For example, if my voice is from 0 to 4 kilohertz, that's my voice range, then the bandwidth of my voice is 4 kilohertz. From 0 to 4 kilohertz. If, for example, that cable operates from 0 to 10 megahertz, then the bandwidth of that cable is 10 megahertz. Do you get me? Bandwidth is basically the frequency range. So bandwidth can be related to our information signal, channel, medium, or devices. For example, the voice, the frequency range from 4 to 4 kilohertz. Then the bandwidth is equal to minus 4000 with 4, 3996, for example. Optical channel bandwidth from 180 to 200 terahertz. So the bandwidth is 20 terahertz. And then we have component like low pass filter from 0 to 500 kilohertz. So the bandwidth of that low pass filter is 500 kilohertz. So if we talk about bandwidth, can be associated with your signal, medium, or communication device. Okay, so bandwidth is related to bit rate. Okay, so bit rate is how many bits per second. It's also related to speed. So if you can transmit larger bits, higher bits in 1 second, of course it will be faster in your system. For example, if I have like my video, my video is 100 megabytes. 100 megabytes. If the medium is allowing only 10 megabit per second, and you compare another one, if I have two mediums, okay, one 10 megabits per second, another one 100 megabit per second. You can imagine which one is faster. Of course, when I transmit, or if I want to transmit my 100 megabyte, the second medium will be faster, because the bit rate is higher. Okay, so that's why bit rate, everyone is very concerned about their bit rates. So recently we had Telecom Malaysia, right? It was fined a huge problem because they promised different thing and then deliver different thing. They promised like 100 megabit per second speed, but then when user detect only like maybe 10 megabit per second, so it's different. But these are the parameters that are important because it determines the quality of service that users experience. So that's why bandwidth is related to bit rate, and signal bandwidth also depends whether it's analog or digital modulation formats. So it's a very valuable resource in a communication system. Okay. So that's why it can be a business strategy, your bit rate, bandwidth, and all this. So all these companies are fighting who can offer more, higher speed. Okay. We have questions here. Normally, when more people connect to a Wi-Fi, the speed become low. Why does this happen? Is it caused by speed or bandwidth? Okay. Basically, when many people connect to Wi-Fi, Wi-Fi has limited spectrum. The bandwidth is limited. So, if you have more people connect, you'll be fighting for the placement of your information signal within the spectrum. So that's why it becomes slower. Like, for example, I have with my Wi-Fi, I have 10 megahertz. If two users use 5 and 5, and 5 megahertz, 5 megahertz. So the bandwidth is also associated with bit rate. Okay, if you take one example where where is it? Okay, bandwidth for RZ here is equal to bit rate. Okay, so let's say we just assume bandwidth equal to bit rate. So 5 megahertz, meaning that each user got 5 megabit per second. Okay, if we assume bandwidth equal to bit rate. But in another situation, when you have more people, the spectrum is still the same. You cannot see the screen. What about other students? Can you see the screen? Probably because of your internet connection, perhaps. Okay. So if you have, the thing is, the spectrum is fixed. The Wi-Fi cannot see too. Okay, is it okay now? I think it's the internet here in UTM, perhaps. Let me. Okay, can now? Okay, maybe because I stayed for a long time in one side. Now, no. Oh my God. Okay, can? All right. Okay, so before we have the spectrum of your Wi-Fi is still the same. It's 10 megahertz, 10 megahertz lah. If you have 5 users, 10 users, it's still 10 megahertz. So if you have 2 users, the 10 divided by 2. If you have 10 users, it's 10 megahertz divided by 10 users. That's why bandwidth, if we assume similar to bit rate or speed, then more users, you get less speed. Okay. Yes. If you have many people in UTM fighting for the same network Wi-Fi, then it's troublesome, especially if many are watching online video. That's the reality lah. All right, and channel capacity. Okay, channel capacity is for this capacity of the channel. It is associated with the noisy environment, the noise in that channel. So it's the maximum rate for information to be reliably transmitted over a noisy communication channel. So C is equal to B log 2 1 plus SNR. So this is known as the channel limit, the maximum capacity, considering the noise. When we take into consideration noise in for your channel capacity. Okay, for a given SNR channel with higher bandwidth has higher capacity. So when you have a larger capacity of even your channels, so here channels mean the medium lah, whether it's wireless or optics. So medium with larger capacity or larger bandwidth, you can support more users. Okay, this is very important part in communication system. Like I think we have. What's the difference between bandwidth and channel capacity? Okay, channel capacity we take into consideration signal to noise ratio, noise. And it's the capacity taking into consideration SNR. Bandwidth is just the frequency. We take into consideration the frequency range. If 5 devices using one modem, mean they sharing one channel or they each have own channel? 5 devices using one modem. If this device, for example, if they use wireless Wi-Fi, so it's the same channel. If you're talking about medium, the channel medium, okay. So this is question from your friend Wei Li Wong. So if 5 devices using one modem, they're sharing one channel, okay. So if they're sharing over Wi-Fi, then it's one channel. If, for example, they have their own Ethernet cable, if these devices connect Ethernet cable, then they have their own channel. But then depends if your modem, meaning that you're subscribed to a certain package, then for each channel the bandwidth will be divided between users. Okay, this is a very important part for the calculation in communication. We use dB a lot in communication because basically dB shows the ratio. Okay, using dB, we can understand how the loss, gain, SNR performance in a communication system. And power in communication can also vary quite a lot. If we are talking about the transmitter tower, it can be in megawatt. If you're talking about input to your phone, maybe in picowatt. Okay, so rather than calculating in linear form, it's more convenient to work in dB. Okay. Okay, so if we want to, I think you have already learned these dB units in your secondary schools. Okay, so if P1 is our reference power, then the 10 log P2 over P1, if you want to talk about the ratio power, if V1 is our reference voltage, we use 20. Okay. There's also terms dBm, dBw, dB volt. So these are power measurements in milliwatt, watt, and volt. Alternately, respectively. Sorry. So dBm, dB watt, dB V, these are the values of power and voltage. They're not ratio. It's just that they're referred to a reference power like 1 milliwatt, 1 watt, 1 volt. Okay. Let's look at examples. Yeah. Okay, so these are examples of the tables for dB units. The one on my left are the ratios, and ratios meaning that you divide P with P. Example, and you want to compare between two power levels. Okay, so if the ratio between them is 10, then it's equal to 10 dB. If there's no difference between two powers, then it's 0 dB. Okay, just 10 log, so you get dB unit. Okay, this is if it's less than 1, the ratio, you get negative. Okay, these are the ratio. On my right hand side is the powers in watts and milliwatts. Okay, so if you look here, the equation P divided by 0.001, and this means 1 milliwatt. So for dBm, the reference is in milliwatt. Here put dBm power in unit milliwatt. So it's 0.001. P divided by 0.001. So if your P is 0.001, which is also 1 milliwatt, then log 10, 1 is equal to 0, times 10 equal to 0, then becomes 0 dBm. So 1 milliwatt is 0 dBm. 1 watt, 30 dBm. So you can use this equation on top. For values of power less than 1 milliwatt, see the same equation, you can get minus dBm. Okay. Okay, all right. Can you follow? Still follow? Okay, good. Okay, let's try this exercise. Calculate signal power if its value in dBm is 0 dBm. Oops. Okay, so I have a common pen, but cannot be used here. I don't know why. So, okay, so your value in dBm is 0 dBm, so you need to calculate the signal power. So you can use this equation. So it's equal to 0. Then we just inverse the anti-log. If you anti-log 0, then you get 1 milliwatt. Okay. Calculate signal power if its value is 1 milliwatt. What's the signal power in dB? Okay, dB, in this case, you are asked to calculate signal power in dB if its value is 1 milliwatt. dB is also, and normally people, they don't use dB watt lah. Sometimes they use dB, and that's the confusion, you know. That can cause confusion lah, but it's quite normal. So if it's dB or dB watt, that is used for to calculate signal power, then sorry, the equation here over here is P over 1, 1 watt. So you don't. So here is your reference power. If it's dB or dB watt, is here is 1, 1 watt. If it's dB micro, then is over here is 1 micro. Okay. So obviously is 0 dBm, 0 dBm in dB is what, minus 30 dB. Okay. Carrier signal is equal to this voltage suppressed by 20 dB. What is the carrier's new amplitude? Carrier's new amplitude. So we have this amplitude, our voltage. We convert it to dB. Okay, let's look at the solution. Okay. So this is the answers for the questions. So if you look to calculate signal value when you are given 0 dBm, so it's 10 log P2 over P1, where P1 is our 1 milliwatt. Okay, because question asked in dBm. Okay, so just anti-log 10 and we get the answer times with 1 milliwatt. So you get 1 milliwatt. Okay. If it's 1 milliwatt, how to change in dB? Okay, so your P2 now is 1 milliwatt. Okay, and P1 is 1 watt. Okay, then you got minus 30 dB. Because P1 here is your reference power. So you need to remember if it's dB watt or dB, your signal power. P1 is 1 watt. If dBm, 1 milliwatt. P1, if micro, dB micro is 1 microwatt. Okay, so for the voltage, and it's equal to 20, the dB is 20 log V2 over V1. Okay. First, we calculate the original 100 volt, which is equal to 40 dB. So if we suppress this by minus 20, by 20 dB, meaning that we minus it by 20 dB, so it becomes 20 dB. Okay, so 20 dB is equal to 10 volt, just anti-log. So the new carrier's amplitude is, the new equation for your carrier signal is 10 cos 10 pi t volt. Okay, I hope you can follow.
Doctor,
Yes.
for exercise 1.2, why the power 1 is 1 watt instead of 1 milliwatt? Does
Which
it
one?
state with the exercise 1.2?
1.2, okay.
Why the P1 is 1 watt? Does it need to, why not 1 milliwatt? Because the question only state dB, right? They did not say whether want to dB watt or dBm, right?
Okay, so if it's dB, if it asks you to calculate or give you signal power in dB, it means dB watt.
So it's like default lah. dB is
Yes.
like dB watt. Okay.
If signal power in dB, meaning because it's in 1 watt. But if it's dBm, P1 1 milliwatt.
Okay.
The reference, because it's 1, right? So that's why sometimes people, they just omit, they don't put dBW.
Okay, got it.
Okay, other questions? Okay, this will come out in your quiz, all this conversion. So you have to understand it well. Too many things to digest. Sorry. Okay. Any more? Can we continue? Quiz is today or this week? You want today? No. The quiz is ready. Yeah, but I want to ask you whether we should do it right after our class or day after or weekend. Okay, we can. Okay, so actually you have learned all this. Maybe you just need to refresh. If you remember, then kata form 4, form 5, I believe you have learned this log, right? Can we switch the reflection to quiz? Okay, reflection actually is just just one paragraph, is just for you to reflect what you have learned. That's all. Yeah, so reflection is mandatory. That is due by tonight. But quiz is in the weekend. Yeah, quiz in the weekend. The link to submit reflection, everything in Google Classroom. It's already there in Google Classroom to submit reflection. But quiz is still, the quiz is already, but I have not shared the link yet. I want to confirm. Okay, reflection does not reflect understanding. It maybe it helps you in expressing your feeling, yeah, and also maybe helps in your writing. Okay, let's continue. Just a little bit more. Okay. I think this is like second last slide. Okay, the transmission types. There are 3 categories: simplex, half duplex, and full duplex. Simplex is one way, and you just receive. What are examples of simplex? Anyone? What are examples of simplex? Anybody? Keyboard, walkie-talkie. You just receive. Okay, so examples are like television, radio. Yeah, we cannot talk back to the television or radio. We just accept their information. Okay. And then we have half duplex. Yeah, half duplex, two-way. Yeah, but only one user can transmit at one time. So this is your walkie-talkie example. Half duplex. Yeah. Full duplex is both users can transmit signal at the same time. This is like our normal, normal telephone. Okay. Kiosk. Where's kiosk? Okay. Both talk at the same time. but whether you can understand each other or not is another story. But you can't all exist at the same time. Okay. But when we communicate, both of us can communicate at the same time right now using Google Meet. So it's an example of full duplex. Okay, this is an example of my reflection, recapitulation, I call it. So communication system has become essential part, but this is quite a long line. To summarize what we have learned, so communication system has become essential part in human's life and is governed by standards and regulations. So all engineering fields will eventually involve in communication part, whether you're from electronics, mechanical, biomedical, whatever. Eventually you will involve communication part, especially with IoT, smart manufacturing. You need to be connected to the cloud. And communication involves three main processes: transmission, processing, receiving, and three main processes of communication system. And our information signal in whatever forms will be processed to a form that is compatible with the transmitter, medium, and receiver. Medium can be wireless or wired. Different medium type subjects to different operating frequency, different attenuation, different loss. And it's very important to master calculation in dV or converting from dV to linear, okay? Because they are widely used in communication system. And finally, don't forget to submit reflection today and prepare for your first quiz, which is scheduled on Saturday, 8 p.m. Okay, so that's the end. Nearly 350. Okay, sorry, 32 slides. All right, so any questions, anything that you want to add? Yeah.
After the class, will you upload the video?
The video?
The recorded
Yeah.
video.
So I will just stop the video. I'm recording actually, but I will stop it now. Okay.
Okay, thank you, ma'am.